right, we are screencasting. This is part 2 for investigation 9A, and we've gone over the basics of this particular diagram, and then we're going to look at this diagram in more detail in just a second. Just remember that your L's represent low altitude, your H represents high altitude, because these are maps of constant pressure. Okay, notice that up here on yours, it's kind of hard to see because it's black and white, but this is blue indicating colder air. Down here is kind of pink representing warmer air. And y'all know that colder air is more dense, so for the same pressure for colder air is going to be found at a lower altitude than that particular pressure in warm air, because warm air takes up a greater volume. All right, so I'm going to keep this image up, but I'm going to be reading number 1 and explaining it, so y'all follow along with me. The ridges of the northern hemisphere's upper air westerlies exhibit clockwise or anticyclonic curvature as seen from above. Well, what does that mean? If you're talking about the H here, and you notice that the westerlies flow this way, notice the little arrowheads, okay? When you get to the H, the ridge, you are going to be turning, okay, clockwise to go up and around that ridge. And that's what they're telling you. As shown in figure 1, a line can be drawn that divides a ridge into 2 roughly symmetrical sectors. So they divided the ridge, okay, and this is a ridge line. Note that west of the ridge line, okay, west of the ridge line is over here. Note that west of the ridge line, winds are from the southwest, which is a warm weather direction. That should hopefully make sense, because if you follow these arrows in this part that's west of the ridge, the air is moving from southwest to northeast. Okay, so it's moving from a direction that would be warmer towards an area that would be colder. Okay, so this is a warm air direction. Okay. And east of the ridgeline, okay, east of the ridgeline's over here. East of the ridgeline, winds are from the northwest, which is a cold weather direction. So if you're in a location that's over here, you're experiencing this jet stream helping bring in cold air because it's coming from the northwest flowing to the southeast. So we'll label that cold. Okay. We can conclude that winds to the west of the ridgeline favor what? Cold or warm air advection, meaning favors bringing in cold or warm air. Okay, here we obviously are bringing in warm air because it's coming from the southwest. Okay, so you need to circle warm air advection, while winds to the east of the ridgeline would favor cold air advection. Okay, so that's number 1. Number 2, the troughs of the upper air westerlies curve counterclockwise, and they are called cyclonic. So if you are at a trough and you are following the arrows, okay, oops, my arm's in the way. If you are curving around the low, notice that you swing in a counterclockwise direction, okay? So if you're here at the low and you're moving with the air, you're turning counterclockwise, okay? All right, so as shown in figure 1, a line can be drawn that divides a trough into 2 roughly symmetrical sectors. So we have a trough line here and another trough line here. Note that west of the trough line, winds are from the northwest. Okay, so here's a trough line. This happens to be west of the trough line. It's east of the ridge line, but right now we're referring to the trough line, and we say west of the trough line. Okay, so west of the trough line, we're getting a cold weather direction because winds are from the northwest. And east of the trough line, over here, east of the trough line, winds are from the southwest, okay, which would be a warm weather direction, okay? And you've got another trough over here. Okay, so let's label these real quickly. This is coming from southwest going northeast. So let me move this out of the way. This is another warm weather direction. Okay, and this one over here is going to be another cold weather direction because it's coming from the northwest. Okay. So now let's answer the question for number 2. We can conclude that winds to the west of a trough line, okay, so here's our trough line, winds to the west of a trough line, west of this trough line, also west of this trough line, favor what? Cold air advection. So it tends to bring in cold air because it's flowing from the northwest. Okay, so number 2 is cold air advection. All right, so now we go on. Again, you're still looking at the diagram, but I'm reading along on the second page. And it says, ridges and troughs usually migrate from west to east over time, so that as a ridge line shifts eastward, a location that has been experiencing cold air advection then experiences warm air advection, and a location that has been experiencing warm air advection then experiences cold air advection. So what they're saying is these troughs and ridges don't stay put. They tend to migrate around the globe slowly. So if, for instance, you're in a town located right here, right now you're close to a ridge. But as these move slowly, eventually there'll be a trough close to you because this ridge has moved off. Okay, so they're just trying to let you know that these do slowly migrate over time. Okay. Number 3. Upper air winds steer low pressure systems as well as air masses. So if you had a surface low that is centered to the east of a trough line and the west of a ridge line, that surface low will be expected to move which way? Okay, so they're saying, let's just pretend we had a surface low pressure system. So one of those little L's that you would see on the weather map. Not the same L as over here, but a surface low pressure. If it was located west of the ridge line, east of the trough line, we're going to put it, in this area somewhere. And you notice that the strong winds are going from southwest to northeast. So you would expect the low pressure system to also migrate in that general direction. Okay? So to answer the question, it says a surface low that is centered to the east of the trough line and west of the ridge line will be expected to move towards in this direction in general is northeast. So there's the answer to number 3. Okay. If for some reason you had a low pressure system here, then you would see that it tends to move southeast. Okay. So these upper air, these jet streams are going to influence what is happening to low pressure, high pressure systems, storm systems and stuff that happen, that affect us on the surface.